No, I told you before. No, Sanke, I don't want to kiss your lucky egg. Oh, hey guys, you gotta quit sneaking up on me. Anyways, let's go ahead and get started with the first lab video. Alright guys, so we're gonna go ahead and start out with lab 1, which is vectors. And this one involves a lot of algebra, geometry, and trigonometry principles. So if you're a little bit weak in those, I suggest you try and find an outside source to help with those. I will, however, do my best to teach those the best that I can. And so on here, there are 3 sections, and I'll do an example problem from each so you guys can get an idea of how to do them. So for the first one, we're looking at x and y components of a vector. So we need to draw out the vector, which is essentially the hypotenuse of our triangle. So beforehand, like I was talking about with the geometry and trigonometry principles, I'm going to briefly go over the applications of the sine, cosine, and tangent and how we're going to use them. So throwing it back to 8th grade here, we have this. I'm sure you guys have seen this before. So this is going to stand for the trigonometric function that we use. So this right here, this is the sine, cosine, and then tangent. And then the opposite is going to stand for, or the O is going to stand for the opposite side. The A is going to stand for the adjacent side. And then the H is going to be the hypotenuse of the triangle. So I'm sure plenty of you guys have seen this before, but I'm just going to briefly go over how to do these. So whenever we have a right triangle, which is going to look something like this guy here, so with 90 degrees, we're going to have our angle of reference that we're looking at, and then so we have our 3 sides here. The slanted side is always going to be the hypotenuse. The closed side, the side that it's touching, is the adjacent side, and then the side across from the angle is the opposite side. So when we're solving these functions, what we're going to need to do is figure out where our angle is and what sides we need to solve for, and then we can use the appropriate trigonometric function. Alright, so back to the first problem. So we have a direction of the vector and then its magnitude. So we want to go ahead and draw out the vector. So we've got a vector going here at approximately 70 degrees. And it's at 350 newtons. So what we need to do is compute the x and the y, which is going to be something like this right here. So we need to figure out the 2 side lengths for this. So right here is our y, and here's our x. So we already have all the things that we need to solve the problem here. So we're going to go back to the sine, cosine functions, and then we're going to be able to solve from there. So let's say we want to go ahead and solve for the x first. We know that the x is also the adjacent side because it's the side that's touching where the angle is that we have the measurement for. So since we're dealing with the adjacent side, we're going to use the cosine function. So we'd say the cosine of 70 degrees is equal to the adjacent side, which we don't yet know, which is x, over our hypotenuse, which is 350. So that's the first part here. So now we're going to go to some algebra for this. So what we need to do is be able to isolate the x. So the way that we're going to do that is multiply each side by 350, which is the denominator. So what we end up with is 350 times the cosine of 70 is equal to x. And also I should go ahead and mention that you guys want to make sure that your calculators are set to degrees for this, because if it's in radians, you'll get a weird answer. So if you're not sure how to do that, the internet is a great tool. Alright, so whenever you put this into your calculator, you'll just have 350 multiplied by the cosine of 70, and for the x component, you should get 119.71. And it's usually best to go ahead and add your units too. So in this case, we're dealing with newtons. So always add your newtons first. Okay. So then for the next component, we're going to look at the y side, and we're going to do the exact same thing, but this time we're just going to use sine. So we'll go here, and so we have our y, so we have the sine of our angle, which is 70, is equal to the opposite side, which is the y, over the hypotenuse, which is 350. So do the same thing, multiply each side by 350, and then we get 350 times the sine of 70 is equal to our y. And when we do that, we'll get 328.89, and then add the units as well. So the two answers that you'll have for this problem are the x is 119.71 and the y is 328.89. And that takes care of the stuff that's in the first section of the problems. All right, so now on to the second section, which is essentially the exact opposite of what we did. Now we're given both sides and we need to find the angle. So what we need to do for that is we need to use the inverse function, which on most of your calculators should look like this. Most of it on your calculators is probably going to look like this guy right here, sine to the -1, and some calculators it might say arc sine. Either way, it'll do the same thing, and what that's going to do is give us two sides, and then we're going to be able to get an angle from that. So what we have here is we have our x and our y, and it's always good to put these on the coordinate system as well. So we have our x, which is 130, and then our y, which is 1200. And it's always best to draw the vector coming out from the center of the axis. So we end up with something that looks like this here. So this side right here is our 130, and this side right here is our 1200. And then what we need to do is we need to find the magnitude, which is the hypotenuse of this triangle, and then we also need to find the direction, which is the angle. So we're looking for two things here and here. So I'll go ahead and draw that out again over here. So what we've got is our initial angle right here. And we have our two side lengths that we know. And then we need to solve for our angle and our magnitude. So we're going to do the same thing as we did before with sine and cosine. This time we're just going to put in the sides instead of our angle. So let's say we want to go ahead and solve for the hypotenuse first. So the way that we're going to do that is use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And what that is you have three sides to the triangle. So the two straight sides are A and B, and then the hypotenuse is side C. So what you end up with is 130 squared plus 1200 squared is equal to C squared. So when you do this first bit, you're going to get a really big number, but don't worry about that because then we take the square root of that to get the hypotenuse or the magnitude. So when we do all this, what we get is, all right, so I didn't have my specific calculations, so I had to go put it in a calculator, but this is what we got. So you take 130 squared and you'll get 16,900, and then 1200 squared and you'll get 1.44 million. And then add those up together, and then we get a really big number, but that's cool, because then we just take the square root of both sides, and then what we get is C is equal to 1207.2. So now we know this side length here to be 1207.2. So that's going to be your answer for the magnitude. So the magnitude is going to equal 1207.2. Now we still need to find the direction, which is another way of saying the angle. So in order to solve the rest of this problem, we can use either sine, cosine, or tangent. As long as we pick the right two sides to use with them, you'll still get the same answer for all of them. So let's say we want to use cosine. So as we talked about earlier, the cosine is going to be the adjacent side, which we know to be 130, over the hypotenuse, which we just found out, which is going to be 1207.2. So when you put this into the calculator, it'll look something like this. So you will do the cosine inverse function of 130 divided by 1207.2. And then when you do that, you should get 83.82 for the magnitude, or sorry, for the direction. So for the direction, it's going to be 83.82. So one thing that's important to look for when we're assessing the direction is that we want to know where our vector lies within the coordinate system. So this spot right here is either the 0 or the 360 degree. This is 90 here, this is 180, and then this is 270. So anytime that we assess the direction of a vector, we need to go counterclockwise. So if we happen to have a vector that exists in the fourth quadrant here, then we would say that its direction, let's say it's approximately 300 degrees. So we're always taking and going counterclockwise from the 0 to measure our angle. And some of these problems you'll only be working in the first quadrant where everything is your positive number, but then other cases you'll have to figure out where the angle is and then count counterclockwise to get the final answer. All right, so for the last section of problems, we're going to combine everything that we learned in the first and the second section and put those all together. So the first thing that you want to do anytime that we're adding the vectors, and like Dr. Ricard will go over in class, the tip to tail method, that's the same thing that we're going to use here. So what you want to do is always draw out your vectors so that you can have a good idea of where it is on the plane, so you know whether to add 180, subtract 180, whatever the case might be, so that you get the proper direction of the vector. So the first problem here, we have a vector, our vector A is 50 newtons at 27 degrees. So it's going to look something like this here. And our vector B is 70 newtons at 145 degrees, which is going to look something like this. So now that we've drawn it out and have a good idea of where the vectors exist in space, we can do what we did for the first two problems and essentially solve the triangle here. So we're going to do the same thing that we did before, and let's say we want to go ahead and solve for our y and our x. So we'll go ahead and take the sine of our x is equal to, the sine of 27 is equal to the opposite, which is the y, over the hypotenuse, which is 50. So we're going to do what we did before, multiply each side by 50, and we end up with 50 times the sine of 27 is equal to our y. And then now we're going to do the same thing for our x using cosine instead. So the cosine of 27 is equal to x over 50. So we end up with 50 times the cosine of 27. So this is what we need here, and this as well. So when we put these into the calculator, what we get are the y is equal to 22.7 and our x is equal to 44.55. So now we're going to do the same thing with the other triangle here. So what we've got is we have our x here and our y here as well. So we'll go ahead and start with sine again. So we take the sine of, you can use either 145, but I prefer to work specifically in the triangle. So I'm going to use 35 because we know that this right here is 180 degrees and this is taking up 145 of that. So if you do 145, then the answer that you get from your calculator is going to automatically make it either a negative or positive value based upon the number that you used. So for me, I prefer to work specifically in the triangle itself. So we'll take the sine of 35 is equal to the opposite over the hypotenuse, which is 70. So again, multiply both sides by 70. And then we'll do the same thing for the x using cosine. So the cosine of 35 is equal to x over 70. So we end up with 70 cosine of 35. And then when we do those in our calculator, what we get is the y value is equal to 40.15 and our x value is equal to 57.34. So now that we've got these two triangles solved, we can essentially do our tip to tail method and then find out the resultant vector, which is what we're looking for. So now that we've got the two vectors solved, we can do our tip to tail method and then figure out the resultant vector. So our initial spot is right here. This is where we're starting from. So this is in the center of our coordinate system. So our first vector, vector A, looked something like this. And then we go ahead and fill in all the information that we had earlier. So we know this to be 44.55 and the height to be 22.7. So this is our vector A. And now our vector B, we put the tail of that one at the tip of A, and it looks something like this here. So we have our x side was 57.34 and our y value was the 40.15. So you'll notice that this is slightly a different way than Dr. Ricard teaches it, but it allows you to prevent errors from happening in your math and getting the wrong answers because you can actually have a visual representation of the vectors themselves. So our vector, our resultant vector, is going to go from here. So it's going to go from the tip of B all the way to the tail of A, so where it started from. So this right here is the vector that we really need to solve for. And so the way that we're going to do that is essentially make another triangle out of it. And I'll draw it separately after I draw it here so it's a little bit more clear for you to see. So we take the side here and we go ahead and drop it down because that allows us to tell the full length of the vector here. And then we'll just draw our center back to the beginning. All right, so drawing it out separately, our triangle is going to look something like this right here. And so we know that our axis is going to look like this here. So we can tell that by drawing it out in the picture here, that we know that our answer has to be greater than 90 because we're in the second quadrant right here. So now we're going to go ahead and fill it in with the numbers that we know. Okay, so the way that we're going to figure out the x distance is since vector B had a x distance of 57.34 and vector A had an x distance of 44.55, we're going to subtract 44.55 from the 57.34. And when we do that, we get a value of 12.79. And since both vectors essentially stack up together, we can just add their y values. So for vector A, it was 22.7, and for vector B, it was 40.15. So when we add those two numbers together, what we end up getting is 62.85. And so now we have the basis of our final vector that we're going to solve, and it's just like the problems that we were doing earlier. So we have our two sides, and then we need to solve for the angle and then the hypotenuse. So we'll go ahead and solve for the hypotenuse here, which is the same thing as the magnitude. So we'll do again a squared plus b squared is equal to c squared. So we take 12.79 square it plus 62.85 square it equals c squared. So when we do the math for that, we end up with, all right, so I went ahead and did the rest of the math for this. So we get, this is 12.79 squared plus 62.85 squared. And when we add that up, we get 4,113.7. And then we take the square root of both sides. And then when we do that, we get 64.14. So that solves our magnitude, which is equal to 64.14 newtons. All right, so now that we've got our magnitude solved, all that we need to do now is find our direction, which is the same thing as saying the angle. So let's go ahead and say we want to use the cosine function. So we'll take the cosine of our angle here is equal to the adjacent side, which is 12.79, divided by the hypotenuse, which we just found out, is 64.14. And then make sure this is the inverse cosine. And so when we do that, we put that into the calculator, you'll end up with the angle, which is 78.48. So, but that's not the final answer yet. So we know that this angle here is 78.48, which is why I suggested drawing it out the way that I did. I know it takes a little bit longer than what Dr. Ricard does, but this way you eliminate any guessing of whether you add 180 or subtract 180. So since we know what it looks like and we know this angle is 78.48, the way that we can solve this is we know this side to be 180. So we just take 180 minus the 78.48, and then that's going to give us our answer. So our final answer for this problem is going to be 101.5 degrees. All right, so that solves up the last bit of the problems. I know it looks like a lot, but if you do it this way and you write out everything, you're going to be less likely to make a mistake. And so just do it step by step. And then when you get to the end, you'll know what your angle needs to be, whether you need to subtract 180, add 180, whatever the case might be. So that finishes it up for the first week of lab, and I'll see you guys next week.